Hello and welcome back to the channel for another video. This video is going to be the Year 6 SATS arithmetic test walkthrough. This is this year's test just gone, and if you're looking to see where your child may have made some mistakes, it's good to have a look and see how each question would have been answered. Or if you're looking to prepare for the SATS next year, this is also a good video to watch. So let's begin. The children have 30 minutes to complete the arithmetic test. Most of the questions are worth 1 mark, with some questions being worth 2 marks, and they can get a mark for showing they're working. The boxes provided here, the children must write their final answers in those boxes provided if they want to get a mark. Okay, so let's begin. Question number 1, 707 take away 10. This is a fairly straightforward question. All they should really need to do is to count back 10. Now, they could do this in their head. So some of the questions you should be able to do in your head. So if we do 707 and we subtract 10, we count back 10, we're going to be left with 697. Okay, so that's just a counting back question. There isn't a particular strategy that you could use. I mean, if you really wanted, you could draw a number line, start from 707 and count back, -1, -2, -3. But the quickest way is just to count back 10 in your head. So number 2, the question is 6,138 plus 456. They've tried to confuse the child by just putting the equal sign in the middle here. But what I say to my children is that this is like a balancing scale. So whatever's on this side has to balance to this side. So all we really need to do is to add 6,138 to 456. Okay, so we're really just adding those together and writing our answer in the box here rather than at the end. So 8 add 6 is 14, 4 down, carry the 1. 5 add 3 is 8 and 1 is 9. 1 and 4 is 5. And then 6 add 0 is 6, leaving us with a final answer of 6,594, making sure to write our final answer in the box provided. Okay. Question number 3, the first multiplication question on the paper, and I would probably say to the children to solve this one using your normal multiplication method. So setting it out like this. Okay, and we're going to start by multiplying the 1. So 2 4s are 8. 0 times 4, 0 times anything is always 0. And 7 4s are 28. And we write both numbers in, leaving us with a final answer of 2,808. Question number 4. Once again, we have a question with an equal sign we have in the middle of the number sentence. So for this one, we're just going to add these two numbers together. So we're going to set it up as column addition. 8,005, add 408. Okay, simple column addition. 5 add 8 is 13. 3 down, carry the 1. 0 and 0 is 0, but add the 1 is 1. 0 and 4 is 4. And 8 add 0 is 8, leaving us with a final answer of 8,413, remembering to write our final answer in the box provided. Okay, number 5. So for this question, we've got 3 numbers that it wants us to multiply together. Now, multiplication is something called commutative, which means that you can actually do this in any order you want and you will still get the same answer. Some questions that involve more than one type of operation, like an add and a divide or an add and multiply, you would have to use BIDMAS to work out the order of that operation. But for this one, like I say, multiplication is commutative, so it can be done in any order. So I could do 2 times 4, okay, which is 8. And then I could do 30 times 8. 0 times 8 is 0. 3 8s are 24. Okay, so if I'd have done it in a different order, if I'd have done 4 times 30, which would have been 12 or 120, then times that by 2, I would have got the same answer. Like I said, this can be done in any order. Okay, here we have another question where the equal sign's been placed in the middle. Again, this is just like a balancing scale. Whatever this side equals must equal this side. So I'm going to do 10 times 96. Now, I would always encourage the children to draw a place value chart when multiplying by 10, 100, and 1,000. In this case, we're just making 96 10 times bigger. And, you know, some teachers would say, oh, just add a 0 on the end, but that's not good practice because it's not always the case. But here, the answer will be 960. And as we go through the test, I will show you another way you might solve this using sort of a place value method. So question number 7, we have our first question involving decimals, and we are required to add decimals in this question. Now, the mistake that children usually make with these kinds of questions is that they don't put the numbers in the right columns and therefore end up adding the wrong ones together. So what I say to them is start with your whole numbers. So we're going to start with 7 here, and we're going to put 6 underneath. And then we're going to put our decimal points in like buttons on a shirt. So 1 next to 7 and 1 next to 6. Then let's put our first decimal number in, so 7.8 and 6.9. And then you can see that we don't have any more decimal numbers here for this one, but we do have for this one, so we'll put those in. And the second most important thing when adding decimals is to remember where we don't have a number to put in our placeholders. So we're going to have 0 and a 0. Really important, those two steps. So lining the numbers up and then making sure where you haven't got a number, you put a 0 as a placeholder. So 0 add 3 is 3, sorry. 0 add 5 is 5. 9 and 8 make 17. So we're going to put 7 down. I'm going to carry the 1. 6 and 7 make 13. And then we're going to add 1, which is 14. Oops. I'm going to write both of those in. And then I'm going to put my decimal point there as well, leaving us with a final answer of 14.753. And we make sure we write our answer in the box provided. Okay, number 8. So once again, they seem to have enjoyed these kinds of questions on this year's paper, where the equal sign is in the middle, and we have to just do the operation as normal, because whatever is on this side must balance to that side. So this time we've got subtraction. I'm still going to use my column method, so 8,217. Subtract 5,463. Okay, get my numbers lined up. 7 take away 3 is 4. 1 subtract 6 we can't do. We can't borrow from the 2 because it's also too small. So I'm going to take from the 8. That becomes 7. That becomes 12, which I then take from there. That becomes 11. And that becomes 11. So we've got 11 now. Take away 6, which will be 5. 11 take away 4, which will be 7. And 7 take away 5, which will be 2. So leaving us with a final answer of 2,754. Writing up our answer in the box provided. Okay, we have a question here, division. Now, interestingly, some children will have tried to use short division for this. So they will have tried to draw the box like this, the bus stop, okay, whatever you want to call it. And they would have put 450 in here. And they would have put 9 on the other side. Now, that's fine. I mean, there's no problem with doing it this way. But what you should try to get to the children to do and encourage them to do is, as a quicker method, can they use their known facts? For example, 45 divided by 9, I know the answer to that is 5. But if our number here is 10 times bigger, which it is, then our answer must also be 10 times bigger. So that would mean that the answer to this question would be 50. But let's just check it. 9 into 4 doesn't go. So we do 9 into 45, which goes 5 times, and 9 into 0 goes 0 times. So the answer would be 50. Let's write our answer in the box. But also, the quickest way would probably be to use your known facts. Now, I know that 45 divided by 9 is 5, so 450 divided by 9 is going to be 50. Okay, next question. We've got a multiplication question here. And this is a fairly straightforward question. And I'm just going to use my multiplication method to do this. So it's going to be 65 multiplied by 8. Now, given that the test is only 30 minutes, these two questions should have taken the children very little time. They should have been able to get through these fairly quickly. 5 8s are 40, so 0 down, carry the 4. And 6 times 8 is 48, plus 4 is going to be 52, leaving us with a final answer of 520. Okay, now you can see I've used a written method for this and a written method for this. For this one, you could definitely use your known facts, but you should have been able to get through these two questions fairly quickly. Question number 11. Now, we do have another question here, which is asking us to divide. But interestingly enough, just like the other question, we can also use our known facts for this one as well. And I am going to use my known facts for this one. So if I know that 28 divided by 7 equals 4, now we have the answer is 100 times bigger here. I mean, the question is 100 times bigger than 28. It's 2,800. So that means that my answer, I'm just going to multiply it by 100. And 4 times 100 is going to be 400. Okay, which would be our final answer. Now, if you ask me, that's quicker than doing short division. Okay, using my known facts in that way, but might not be the most comfortable way for your child, so it's completely up to them. Okay, here we've got 801, take away something is 795. Now, interestingly, unlike the other questions, this is not a balancing one because we've got a missing box here within the number sentence. So what the children should be doing is thinking about, what do I need to take away from this number here to get to 795. Now, there's two ways they can do it. They can go count backwards from 801. So if I count back, I don't know, easily just take away 1, that gives me 800. Okay, and then if I take away 5, that gives me 795. So that means that altogether I have taken away 6. So that's one way they could do it. Or they could count forward, so they could start with 795, and then they could add 5 to make 800, and then they could add 1 to make 801. Again, two different ways of doing it, counting back or counting forward, but both would bring them to the right answer. Okay, next question. Once again, a division question. And we've got another one where we can use our known facts. So if I know that 27 divided by 3 equals 9, and this is why it's so important for children to know their multiplication tables, then 2,700, okay, is 100 times bigger than 27. So I'm going to make this 100 times bigger. I'm going to multiply it by 100. Leaving me the final answer of 900, which would be the answer to this question. Okay, here we have our first sort of fractions question, number 14. And we've got two fractions to multiply together. Now, it's very straightforward. So there are many types of different fractions questions on the test, but this one's very straightforward. All that you need to do is to multiply the bottom, and you need to multiply the top. So if I do that, 7 times 9 is 63. So 63 would be my denominator. And 2 5s are 10, leaving me with a final answer of 10 over 63. And in this case, it can't be simplified. So 10 over 63 would be my final answer. Question number 15. So here we have another division question, but interestingly enough, unlike the previous three, it's not possible for us to use our known facts. Just looking at those numbers, they don't look like they go easily into each other. So the other possibility here is that this might be a remainder. Okay, so I'm going to set this up with my bus stop method. And just as a tip for you guys, a lot of the short division questions in the arithmetic paper are remainders, whereas a lot of the long division questions, 99% of the time, they tend not to be. So, well, 9 into 7 doesn't go. 9 into 74. Well, 9 times 8 is 72, so I'm going to put the 8 here. 9 times 9 will be 81, which would be too big. 72 with a remainder of 2, because 74 take away 72 is 2, which means that we've got to do 9 into 27, which is fairly straightforward. It goes in 3 times. So in this case, there isn't a remainder. But you do need to remember to write your final answer in the box 83. Okay, 16, we have an adding fractions question. Now with this one, we've got 2 fractions with different denominators. So we need to make sure that our denominators are the same in order to add these together. Now, sometimes I would get the children to list the multiples of 16 and 8 and find the lowest common multiple. But in this case, it's fairly easy to see that what's happened to 8 to make it into 16 is we've multiplied it by 2. So I'm going to keep 3/16 the same. But to get this to 16, I'm going to multiply it by 2. Okay. And whatever you do to the bottom, you must do to the top. So then if I do 5 times 2, I'm left with 10. So that means that 5/8 is equal to 10/16. And now that I have them both the denominators the same, I can now add these together. So 3 and 10 makes 13, leaving me with a final answer of 13/16. Remembering to write my answer into the box provided. Okay, let's move on. Okay, so I did tell you earlier that I was going to show you a question that needed a place value chart. Now, I know that some children might be able to do this quickly or do it in their head quickly, but I see so many mistakes where children have maybe put the numbers in the wrong places, and it's always good practice to check your answer by using what's called a place value chart. So I encourage my children to draw these out, even in the test, to double check. So here we've got 0.3 divided by 10. So I'm going to put tens, I'm going to put ones, decimal points would go here, and then I'm going to put tenths and hundredths. Okay, and you don't have to write these exactly right. And the third column will be thousandths. Okay, and what they need to do is, if you're dividing by 10, okay, what you need to know is that the numbers are going to go backwards. First of all, for divide, they're getting 10 times, it's getting 10 times smaller. So we're going to do one jump. Okay, one jump. If we were dividing by 100, okay, it will be 2 jumps. And dividing by 1,000, the numbers would make 3 jumps. So 0.3. And the 3 is going to make 1 jump backwards into the hundredths column. And we can make the 0 jump backwards again. Okay, and then we need another 0 here. So the final answer would be 0.03. And you may have been able to do that in your head, but it's just good practice to just draw out that place value chart to make sure. Okay, here we've got question 18, and we are adding 3 fractions this time, but all 3 of them have got different denominators. So I'm going to need to make all those denominators the same. And it's most likely that they're all going to be 18. Just looking at these numbers, I can see that 3 goes into 18 and 6 goes into 18. So let me show you a way that you can do it, finding the lowest common multiple. So first of all, I'm going to keep 5/18 the same, because I'm going to change all of these to have the same denominator, and that's going to be 18. Then I'm going to do the 3 times table. So 3, 6, 9, 12, 15, 18, and I'm going to do the 6s, 6, 12, 18, and from listing the multiples I can see that 18 appears in both, and it's my lowest common multiple. So that would be my denominator. But remember the rule from the previous question, whatever I do to the bottom, I must do to the top. So how have I got from 3 to 18? I've multiplied it by 6. So I'm going to do 1 times 6, which is 6, because the 1 here. How do I get from 6 to 18? I'm timesing it by 3. So I'm going to do 2 times 3. Okay, multiply whatever I do to the bottom, do the top. 2 3s are 6. Okay, and now I've got all of these with similar denominators. So now I can add them together. 6 and 6 is 12, plus 5 is going to be 17. 17 over 18. I don't think I can simplify this question. So my final answer is 17 over 18. And I must remember to write the answer in the box provided. Okay, moving on. Question number 19, and for this one, we've got 2 decimal numbers that we need to add together. So, again, what I said to you in the other question, it's most important to make sure you have your numbers lined up. So I'm going to have 29.5, so whole numbers first, so 29, and underneath I'm going to put 16. And then I'm going to put my decimal points in like buttons on a shirt. It's a nice way of remembering it, just one underneath the other. And then I'm going to line up my other numbers. So I've got 5/10ths in this number. I've got 1/10 here. And then I've got 200ths and 5,000ths. And the second important step is to make sure where I don't have a digit, I put in 0 as my placeholders, particularly as this is a subtraction question. Okay, so I've got my numbers lined up. Now I can just subtract as normal. 0 take away 5 I can't do. 0 take away 2 I can't do. It's going to borrow from the 5. That becomes 4. That becomes 10, which I borrow from, which becomes 9. And that becomes 10. 10 take away 5 is 5. 9 take away 2 is 7. 4 take away 1 is 3. Decimal point. 9 take away 6 is 3. And 2 take away 1 is 1. Leaving us with a final answer of 13.375. Okay, moving on. So now we start to have the more tricky questions on the paper, and the first of which is a long multiplication question. And an encouragement here to show your method, because it's 2 marks, and even if the children get the answer wrong, they could still get a mark for showing their working. So starting with the ones, 8 4s are 32, 2 down, carry the 3. 0 times 4 is 0, plus 3 is 0. 5 4s are 20, so I'm going to put both of those in. Now we multiply the 10s. So the really important step now is to remember to put your 0 into the ones column, because we are working with 10s. So we put a 0 as our placeholder. 8 times 7 is 56. 6 down, carry the 5. 0 times 7 is 0, but we have the 5 here that we've carried, so we need to put that down. 5 7s are 35. And the final step when we're doing these long multiplications is to add those 2 parts together. So 2 add 0 is 2, 6 and 3 is 9, 5 and 0 is 5, 2 and 5 is 7, and 3 add 0 is 3. Leaving us with a final answer of 37,592. Now, if you don't put the comma in, you won't be penalised for it, but it's good practice just to put the comma in there to show where the tens of thousands are. Question number 21. So looking at this question, your child might find it quite tricky, but actually there is a quick way of doing this. So it's asking us to divide what would be the fraction of 1/8 into 3 smaller parts. The best thing to do is to look at the numerator and think, can I actually do 1 divided by 3? No, I can't. So in that case, what you say is you do 8 times 3. You multiply the denominator to make those 8 into smaller fractions. So I'm going to do that. I'm going to do 3 times 8, which is 24. And then all I do is keep the numerator the same. And that's it. That's the answer, 1 over 24. So although it might seem tricky to look at, it's a very simple question to answer. 1 over 24 is the answer. Question 22. So here we have adding fractions, same denominators, but we've got a mixed number fraction really, because this is a whole number here. So what you want to ask the child to look at, what you want to look at here is, what is 1 in sevenths? Well, 1 whole in sevenths would be 7 sevenths. So I'm going to convert that into sevenths. And now I can add it to 2 sevenths. So 7 sevenths add 2 sevenths is going to be 9 sevenths. And then I'm going to add that to 5 sevenths. And 9 sevenths add 5 sevenths is going to be 14 sevenths. You could give the answer of 14 sevenths. However, if we really think about this, these two here, they make 7 sevenths, okay? And if I convert this into back into a mixed number fraction from an improper fraction, 2 sevens are 14. So here what we've essentially got is we've got 1 whole here, and we've got 1 whole here. So when I think about it that way, 1 and 1 makes 2. So the answer is actually 2. Okay, 14 sevenths could be considered a correct answer, but the answer is also 2. Okay, because if I did 14 divided by 7, the answer would be 2. Okay, this line here could also be used as a division sign as well. Okay, so question 23. First question here really on the paper where we're going to be having to use BIDMAS. Okay, BIDMAS. We teach the children BIDMAS because it helps them to understand the order in which an operation should be done. For example, B stands for brackets. Okay, I is to the power of, so any squared or cube numbers. D is obviously division. M is multiplication. A is addition, and finally S is subtraction. So looking at this question, it is important in which order you do it in. So when we look at this, we've got 48 divided by 6, which would mean division first. Okay, because look, D comes before A in our BIDMAS word. So 48 divided by 6, this is where you need to know your times tables again, would be 8. Okay, so 48 divided by 6 would be 8. And then I can add that to the 70. So I can do that bit second. And 8 add 70 is very simply 78. Let's put our answer in the box. Okay, question number 24. So here we have a decimal number multiplied by a whole number. Now you could just do this as a sort of long multiplication question in this way. There's nothing wrong with doing it that way, but a way that I like to teach the children here is to look at the numbers and have a look to see what I could do. So 3.2, why don't I make this into a whole number? Now to do that, I must multiply it by 10 to make it into 32. Now I've done that, I can then multiply that by 12. So 32 times 12, 2 2s are 4, 2 times 3 is 6, placeholder, 2 times 1 is 2, and 1 times 3 is 3. And if I add that together, I get a final answer of 384. But remember what I did at the very start. I multiplied 3.2 by 10 to make it into a whole number. So what I have to do is I have to divide that by 10 to get my answer at the end. 38.4 divided by 10, sorry, 384 divided by 10 would therefore be 38.4. Okay, question number 25. So this is our first question where we're being asked to do some long division. Now, the most important step with this kind of question, it's a 2-mark question, so we must show our working. And the first part of our working is to do what's called jottings. And once you've done your jottings, J for jottings over here, it becomes much easier to solve this question. So when I say that, we need to work out what the 47 times table is. So we're going to do 47 times 1 is 47. Now I'm going to write them down, but your child might need to do additional jottings. So like 47 times 2, 47 times 3, to get this run of 47s. Okay, so I'm just going to go through it. 47 times 2 is 94. 47 times 3 is 141. 47 times 4 is 188. 47 times 5 is going to either end in 5 or 0, and it's 5. It's 235. Okay, I'm going to go up here now so I don't write into the box. 47 times 6 is 282. And finally, I only ever go to 7. Sometimes you have to go further than that, but I usually only go to 7. So 47 times 7 is 329. All right, now I've got my jottings. I've got my 47 times table. I can start to solve this. So 47 into 6 doesn't go. Put a 0. 47 into 61. Now looking down here, actually it's only going to go in once, isn't it? So I'm going to put 47 here. Okay, 1 take away 7 can't do. So I'm going to borrow from the 6. That becomes 5. That becomes 1. 11 take away 7 equals 4. And 5 take away 4 is 1. Now, the next step is to bring down the 1 here. Bring that down to make 141. And how many times does 47 go in? Oh, I must remember to write down. It went in once, didn't it? Here. And how many times now does it go into 141? Well, that's easy. It goes in once, twice, 3 times. So I write the 3 up here. And just to finish off, I'll write 141 underneath. And if I take away those, I'm going to be left with 0 because there's nothing going to be left. So that means my final answer for this question is a whole number, and it's 13. Like I was saying to you before, most of the long division questions, the answer to those questions will be a whole number. 99% of the time it will. But yeah, we have to always be prepared. But 99% of the time, the long division questions are whole numbers. All right, moving on then. Question 26. So interestingly, we've gone from long division to short division now. And the reason I chose short division is because we've only got a 1-digit number here. So, I mean, some children prefer to use long division for everything, but really short division should be quite appropriate for this kind of a question. So 5,746, and we divide by 5. So first 5 into 5 goes once. 5 into 7 goes once with a remainder of 2. 5 into 24, 5, 10, 15, 20, goes 4 times with a remainder of 4. And 5 into 46 goes 9 times, 5, 10, 15, 20, 25, 30, 35, 40, 45. It's going to go 9 times, but because it's 46, we're going to have a remainder of 1. So our final answer is 1,149, remainder 1. 1,149, remainder 1. Okay, 27, and our first percentage of amounts question. So with this question, there's lots of ways you can do it. You could find 10%, 2%, and multiply them together, or add them together, should I say. But the quickest and most effective, efficient way, I think, here is to multiply the numbers together and then divide them by 100. And this is the way that I teach all the children in my school. So it's going to be 700 times 52, first of all. Because they're used to using long multiplication, it's just an easier way. It's nothing new for them. 0 times 2 is 0. 0 times 2 is 0. 2 times 7 is 14. And now we need to put a 0 as our placeholder. 0 times 5 is 0. 0 times 5 is 0. 7 5s are 35. And now I need to add those together. So 0 add 0 is 0. 0 add 0 is 0. 4 add 0 is 4. 1 add 5 is 6. And then add the 3. And the final step is to divide that answer by 100. And in this case, the quick way to do it is just to cross out those two zeros, okay, because we're dividing it by 100, leaving us with a final answer of 364. Moving on. Okay, so 28, we have another division of fractions question. And once again, like I said in the other question, first of all, can you split 1 into 6? Can you do 1 divided by 6? No, you can't. So in that case, I'm going to do 3 times 6, okay, which is going to be 18. And I'm going to keep my numerator the same. So the answer to this question is quite simply 1/18. Number 29, and we have another 2-mark question. It's long multiplication, and it's a bit bigger this time, so we need to make sure we follow all the steps carefully. So first of all, the ones. 7 3s are 21. 1 down, carry the 2. 2 3s are 6, plus 2 is 8. 2 3s are 6. And 3 5s are 15. Okay, now we're going to put 0 as our placeholder. It's a bit big, that one. Let me get rid of that. So we're going to put 0 as our placeholder. And now we're going to do 7 times 4, which is 28. So 8 down, carry the 2. 2 4s are 8 plus 2 is 9 10. So 0 down, carry the 1. 2 4s are 8 plus 1 is 9. And 4 5s are 20. Now, if we add these together, it's 1 add 0 is 1. 8 and 8 is 16. 6 down, carry the 1. 6 and 1 is 7. 5 and 9 is 14. So 4 down, carry the 1. 1 and 1 is 2. And 2 add 0 is 2. Leaving us with a final answer of 224,761. And we need to write our answer in the box provided. 761. Very important to show your working as well with these questions, as if you get the answer wrong, you could still get a mark for showing your working. Question number 30, we've got another percentage of amount question. So we're doing 95% of 180. 0 times 5 is 0. 8 times 5 is 40. 0 down, carry the 4. 1 times 5 is 5. Add 4 is 9. Okay, then we put 0 down to placehold. 0 times 9 is 0. 8 times 9 is 72. 2 down, carry the 7. 1 times 9 is 9. 9 adds 7. 1 times 9 is 9. 9 adds 7 is 16. 0 add 0 is 0. 0 add 0 is 0. 2 add 9 is 10, 11. 11 down, carry the 1. 6 and 1 is 7. And then 1. So once we've gotten to that answer, we can now divide it by 100. So take off the 2 zeros, leaving with the final answer of 171. Okay, question number 31. 0.4 times 37. So for this question, like I did with the other question, I'm going to multiply 0.4 times 10 to give me 4. And then I'm going to do 37 times 4. So 7 4s are 28, 8 down, carry the 2. 3 4s are 12, and 2 is 13, 14. But just like I did with the other question here, I've made 0.4 10 times bigger, so then I need to divide 148 by 10 and make it that 10 times smaller again. So it's going to be 14.8. And let's write our correct answer in the box provided. Okay, question number 32. So 32, we have a whole number, and this time we've got a missing box again, and take away 7/10. So for this question, we need to imagine that this whole one here is also in tenths. Now, one whole as tenths will be 10/10. And that makes it a little bit easier to think about, because what do I take away from 10/10 to make 7/10? And it's just simple number bonds here. So now it's going to be 10/10 take away 3/10. Okay, would be 7/10. Now, if they wrote 3 in this box, that wouldn't be correct, because we are taking away a fraction here. So just be careful, although it's set up this way, not to write 3. The answer is 3/10. Okay, question number 33, and we have another long division question. And we've got 2 marks, and we must show our working. So we're going to start off by doing our jottings, as we did before. So we're going to do 26 times 1 is 26. And again, your child might need to do some additional jottings to work out 26 times table, but I'm just going to do it here now. So 26 times 2 is 52. 26 times 3 is 78. 26 times 4 is 104. 26 times 5 is 130. And 26 times 6 is 156. So once I've got my jottings here, I normally go to 7, don't I? So 26 times 7 is 182. And once I've got my jottings, I can start to work this out. So 26 into 4 doesn't go. 26 into 44 goes only once. So I'm going to put that here. I'm going to subtract. 4 take away 6 can't do. I'm going to borrow. That becomes 3. That becomes 14. 14 take away 6 is 8. And then 3 take away 2 is 1. Now I'm going to bring the 7 down. Okay, so now we're doing 26 into 187. Now it's looking to me like it's going to go in 7 times, because I've got 182 here. So first of all, it went in once, and now it's going in 7 times. I'm going to put 182 here underneath. It wouldn't go in 8 times, because if we add 26 to 182, that'd be too big. 7 take away 2 is 5. 8 take away 8 is 0. And 1 take away 1 is 0, which means we just left with 5. But we must remember to bring down the 2 now. And how many times does 26 go into 52? Well, that's easy. It's going to be twice. And just like with our other question, our long division works out quite nicely as a whole number with no remainders. So the final answer is 172. Moving on. Question number 34. So here we have a fractions question. And this question is going to be, well, it's a mixed number fraction, take away and another fraction, but we're going to have to make these denominators the same. So first of all, I'm going to turn this number into an improper fraction. So the way I do that is to do 2 times 6, which is 12, then add the 5, which makes 17. So now we've got 17/6, take away 3/4. But I need to then make these to have the same denominator. So I'm looking for a lowest common denominator of both 6 and 4. Now, I could list the multiples, but an easier way to do it would just be to think, well, what if I did 6 times 4? And that would give me a number that both of them went into. So 6 4s are 24. So that's going to be my new denominator for both. And then it's whatever I do to the bottom, I must do to the top. So how did I get from 6 to 24? I times it by 4. So I do 17 times 4, which makes 68. And then I'm going to do, how do I get from 4 to 24 times by 6? So I'm going to do 3 times 6, which is 18. So now I've got 68 add 18. And you might have to do column method for this. But it would give me a final answer of Oh, sorry, no, I've made a mistake here. I'm actually taking away, not adding. So I'm going to do 68 take away 18, which gives me 50. So I've got 50 over 24, and I can simplify that. If I half both these numbers, half 50 is 12. Sorry, half 50 is 25. And half of 24 is 12. So that gives me a final answer of 25 over 12, which would be correct. Okay, question number 35. I've got another percentage of amount question here. So once again, I'm going to start off by doing 750 times 38. And then I'm going to divide my answer by 100. So 750 times 38. 0 times 8 is 0. 5 times 8 is 40, so 0 down, carry the 4. And then 7 8s are 56. 56 plus 4 is 60. Okay, now I'm going to multiply the 10, so 0 is my placeholder. 0 times 3 is 0. 5 3s are 15. 5 down, carry the 1. 3 times 7 is 21, plus 1 is 22. And let's add those bits together. So 0, 0, 0 add 5 is 5, 2 add 6 is 8, and 2. And the final part of this is to divide my answer by 100, so I'm going to cross out those two zeros, leaving me with a final answer of 285. Okay, so we come to the final question on the paper, and this is 2/3 multiplied by 900. Now, what I say to all my children is when you have a multiplication sign like this, it also means of, which then means that this is actually a fractions of amount question. So I'm doing 2/3 of 900, and this very simple method for that is to divide by the bottom and then multiply by the top. So I'm going to do 900 divided by 3, which is 300. Using my known facts, 9 divided by 3 is 3. And then I'm going to do 300 times 2, because I'm multiplying by the top. 300 times 2, which gives me a final answer of 600. And again, remember to write your answer in the box provided. So that was the Key Stage 2 Year 6 2023 arithmetic paper walkthrough. I hope you found it useful. Thank you for watching, and please subscribe to the channel if you haven't already. And thank you for your support if you have subscribed to the channel. And yeah, subscribe for more videos on primary education, and I will see you in the next one. Thanks for watching, guys.